All right, let's talk about something that makes a lot of people's heads spin, quadratic equations. But what if I told you the secret isn't about memorizing more formulas? What if it's about learning to actually see the answer? Stick around because we're about to completely change how you look at these things.
So, does this look familiar? Yeah, that jumble of letters and numbers. Your textbook swears there's an answer in there, but you're just staring at it and nothing. Don't worry, you're definitely not alone. That feeling of just drawing a blank, we're going to fix that right now.
But here's the thing. The game completely changes when you just shift your perspective a little bit. What if instead of wrestling with all those abstract symbols, you could just look at a picture and literally see the solution laid out for you? That's exactly where we're headed.
Okay, first things first. Let's get real about why this topic trips so many people up. And here's a little secret. It's probably not because you're bad at math. Nope. It's because of how we're all taught to look at it. This, right here, really gets to the heart of the problem. On one side, you have these abstract symbols and that long, confusing quadratic formula. On the other side, a simple, intuitive, U-shaped curve. Think about it. Our brains are wired for visuals. You remember faces way better than you remember names, right? Well, the same logic applies here. A page full of formulas is super intimidating, but a simple curve, that's something we can actually wrap our heads around.
So let me introduce you to the big aha moment that's going to make this all click. I like to call it the parabola story, and trust me, it's the key to making all of this finally make sense.
Think about it this way. Every single one of these quadratic equations you'll ever see isn't just a math problem. It's a story. It's the story of a U-shaped curve, and that curve is called a parabola. And the question it's asking is so simple. Hey, where do I cross that main horizontal line, the x-axis? That's literally it. The solutions we're trying to find are just those crossing points.
So how do we read this story from the equation? It's actually pretty easy. First, just know that any quadratic equation makes this U shape. Second, the solutions, you'll also hear them called roots, are just the spots where that curve hits the x-axis. And here's my favorite visual trick. Just look at the very first number, the one in front of the x squared. If it's positive, the parabola opens up like a smile. If that number is negative, it opens down like a frown. Simple, right?
Now, you want to know a secret that makes you look like a math genius? It's being able to predict the answer before you even start doing all the calculations. Let's check out a really powerful visual hack that lets you do just that. The key is a cool little tool called the discriminant. Now, forget the fancy name. Just think of it as a secret code hidden inside the equation. It's a really quick calculation that tells you exactly how the story's going to end. Is the parabola going to cross the line twice, touch it just once, or miss it completely? This is your crystal ball.
Okay, so scenario number one. If you do that little calculation and the discriminant is any positive number, that's your big clue. It means your parabola is going to swoop down and cut right through the x-axis in two different places. So you know right from the start, you're looking for two different answers. Now, what happens if the discriminant is exactly 0? This one's special. It means the parabola comes down and just perfectly kisses the x-axis at one single point. So you're only looking for one repeated answer. This happens a lot with things called perfect squares.
And the last case, what if that discriminant number is negative? Well, that means the parabola completely misses the x-axis. It just floats there, either totally above it or totally below it, never once touching. And what does that mean for you? It means there are no real solutions to find. This little check can save you a ton of time.
All right, here's another absolutely beautiful visual tool. It not only helps you understand this stuff on a deeper level, but also helps you check your work. It's all about balance and symmetry.
Now this is such a cool concept. Every single parabola is perfectly symmetrical. It's like a mathematical mirror. And what that means is its roots, the solutions. They aren't just random points. They're always perfectly balanced, one on each side of a secret middle line.
And that middle line has a name, of course. It's called the axis of symmetry. And there's a super simple formula to find it. X equals negative b divided by 2a. This little thing gives you the exact center of your mirror. And that's absolutely crucial for checking if your answers make sense.
Let's see this in action, because this is where it gets good. Take this equation. Using our little formula, the axis of symmetry is at x equals 3. Okay, now the solutions to this equation happen to be 2 and 4. And look at how they're perfectly balanced. The first root, 2, is exactly 1 unit to the left of our center line, and the second root, 4, is exactly 1 unit to the right. See? Perfect symmetry. It is a fantastic way to instantly know if your answers are.
So, what does all this visual stuff mean when you get one of those dreaded word problems? Well, this approach is your secret weapon, especially when a problem starts asking for a maximum or minimum something.
Here's the translation key you need. Whenever a word problem about, say, profit or hike or area asks for the maximum or minimum, I want your brain to immediately think vertex. That's just the tip of the parabola, either the very bottom of the smile or the very top of the frown. The question is secretly just asking you to find that one point.
Let's use a classic example. Finding the maximum height of a ball you've thrown. The path of that ball is a downward-facing parabola, right? So the maximum height is just the vertex. We can find the time it takes to reach that height using our axis of symmetry formula, which gives us 2 seconds. Then you just plug that time back into the main equation to find the actual height. And boom, there it is, 21 meters. No more guesswork, you're just visualizing the peak of the curve.
Okay, so you've learned the story, you've learned the secret predictive code, the symmetry check, and how to use it in the real world. Let's wrap this all up into a neat, actionable toolkit that you can start using today. Now, the key is not to try and do all this at once. Build the habit one step at a time. For the first week, just focus on one thing. Sketch a quick, rough parabola for every single problem you see. Week 2, start playing that prediction game with the discriminant. And then, by week 3, start using the axis of symmetry to double-check that your final answers are balanced. This way, you'll build that visual intuition naturally, without overwhelming yourself.
And here it is, your complete visual toolkit, all in one place. Just remember these 4 key ideas. Every single equation is just a story about a parabola. The discriminant lets you peek at the ending before you even start. Symmetry is your secret built-in answer checker. And the vertex, that's the hero for all those maximum and minimum problems.
So, here's the really big takeaway. We've taken something that felt abstract and confusing and turned it into an intuitive, visual story. And you know, this isn't just about quadratics. This is a whole new way of thinking about math. Which leaves me with one final question for you. Now that you can see the picture behind these equations, what other math rules are out there just waiting to be visualized?